We're going to bring everything together now. Get ready for this latest version. The code has really grown. Fortunately, it's really just one main function that we're using. We have added a helper function that simply displays a message in our message area. As we provided for multiple error points, we noticed that we were duplicating the same code over and over. What does that mean? Time to move it to a function. Now, if we need to make changes to how we display error message, or maybe record them on a server somewhere, we only have to make changes in one place. We can also display non-error messages for debugging or informational purposes. We're following the rules and using a single object parameter for any options that this function takes or will take in the future. Notice what we do if we don't get an object parameter to this function. Since the purpose of this function is to display a message, we populate the object with an error message that indicates the function wasn't called properly. This may not be ideal for a production system. We're just using this as an example of an alternate way to set up a default parameter object. The load section has expanded a bit, but it's not really doing much more than it was before. It's just handling errors better. Notice how we're handling the lack of an object parameter now. Instead of only reporting an error to the calling code, we're also making an entry into the message area. We've made allowance for a third property on the parameter object. The dynamic property will default to false, so the calling code will have to set it to true when it's needed. What's it for? It's how the calling code indicates that the page that is being loaded also contains dynamic content. We add extra processing in that case, but there's no need to do it if the page to be loaded doesn't have dynamic content. Next, we've expanded how we handle a missing URL error. Before, if we had two errors, we only saw the first one that was encountered. Now we're placing all error messages directly on the message div. We've gone back to using the get method instead of the load. Why? Because we want to be notified of any loading failures. The load method makes no distinction between completed with success or completed with a failure. It just reports when it finishes. We'll use the get method because it will return a deferred object to us. We pass an empty callback handler function to the get method. We're not really interested in a callback function. Now that we know how to use the done and fail methods, we would rather construct our code using those. The final parameter for the get method tells jQuery that we're loading HTML content. This is an obvious opportunity to extend our parameter object to let the calling code modify this if XML, JSON, or some other format needs to be loaded. We'll save that for another day. Notice how we resolve the deferred object in the done method for the get. If dynamic content is not expected, we can go ahead and resolve our object. That's because we don't have to worry about any long-running process that might be going on for the loaded page. If we encounter a failure with get, we'll report that and reject our deferred object and pass along the result from the get method. If dynamic content is expected, we first remove any event handlers for the complete and failure events. These are custom events that we're going to fire as needed. If this page gets reloaded over and over, it's possible to have multiple event handlers attached each time the page is refreshed. Using the off method removes any previous event handlers of the specified name. In this case, we're making sure that there are no event handlers for the complete event or the failure event. We'll look at how we trigger these events in just a moment. We follow up by adding event handlers to the div by using the on method. The on method is the opposite of off. It adds the specified function as an event handler for the named event or events. We were able to remove event handlers for complete and failure events with a single line. Since we want to do different things for each of these events, we specify different handlers for each one. First, we handle the complete event. When we receive that event, we just resolve our deferred object. This event is fired when the dynamic content of our loaded page is completed. That means any content page will need to trigger this event when dynamic content is done loading. The failure event means something went wrong in the dynamic content and we want to report it. Events can contain additional information and we look for that in the result parameter. The event parameter contains the same kind of information available to any event used by the system, such as click, blur, or mouse over. We're not really interested in that information. We really want to know what went wrong. That information is passed by the content page in the result parameter. After we report the error, we reject the deferred object with the result we received. Let's stop right here and look at how the content page can trigger these events. It's a very simple interface. We trigger the complete event on the Content1 div as soon as we finish processing. Anything that's listening for that event will get notified. Notice that we're triggering the event on the locally defined Content1 div. Our load section code is listening for the event on the div with an ID of section 1. How can this work? The reason this works is because events bubble up the DOM. Since there's no event handler for Content1, the event rises up to the containing element. In this case, that's the div with an ID of section 1. That div does have a handler for this event, so it gets processed. Using this bubbling feature of JavaScript events, we can trigger the event on a local div that this code knows about. We can handle that event with an element higher up the DOM chain. This content page does not need to know anything about how it will be included in the main page. This lets the content page remain completely independent from the page that will make use of it. One more thing to notice before we leave this page. The timeout value has been increased to 5 seconds instead of the previous 2 seconds. That will make this the longest running process in our 3 samples. Let's look at how we can handle a failure event. The failure event is triggered just like we did for the complete event. In this case, however, we pass an object parameter which contains our status text message. As before, the event is triggered on the local div, and we're counting on event bubbling to pass the event up to the containing div on our main page. Back to our load section function, there's just one more condition we have to handle. We've expanded the error handling used in case the selector can't be found. Now we're displaying an error message as well as rejecting the deferred object. Finally, we change the return value to be a promise and not the whole deferred object. This means we can be certain that the calling code will not interfere with how the deferred object gets resolved. Let's look at how we can use this new logic. First of all, notice that we've included calls to the show message function. How can that work? It doesn't return any results, much less a deferred object. This is yet another powerful feature of the jQuery deferred object. Remember, the when method creates a deferred object that processes a group of other deferreds. If any of the processes don't return a deferred object, as our show message function doesn't, it will treat that function as being a resolved deferred object by default. That means we can intermingle synchronous processes with asynchronous processes. Any synchronous processes will be resolved immediately, and processing will continue when the asynchronous process is complete. Think of how we'd have to structure our code to accomplish the same thing without using deferreds. It would be very messy and certainly difficult to maintain. Notice how the load section function calls for Content1b and Content3a have the additional dynamic property. What would happen if we forgot to include this? If we omit the dynamic property when loading a page that has dynamic content, the deferred object would be resolved before the dynamic content finishes loading. That's the behavior we've seen so far. By including this property, we inform the load section function to wait for the complete or failure events before resolving or rejecting the deferred object. What would happen if we include the dynamic property for a page that doesn't trigger the complete or fail event? The deferred object used by the when method would never resolve. We'd have to have some sort of master monitoring process that looked for that contingency. Let's take a look at this latest version. Finally, the Proceed button didn't get enabled until all the dynamic content was loaded. Our page is working just as we want. Many developers would stop right here. We know better, however. We know that we should do some negative testing. Let's start breaking things to see what happens. Let's see what happens when we give it a bad URL. Remember, before we got a cryptic URI message. Here I changed Content1b to Content1bb. We get 2 error messages. The first one is generated by the load section function. Notice how it is more useful because it gives the URL that can't be located. Why did we get 2 messages? We got 2 because the second message is in response to our fail method that's part of the when block. Since our eyes were immediately drawn to the error message, we may have missed a very important point. Let's watch the load process again. This time, Pay attention to section 3 and the Proceed button. Aha! The Proceed button is enabled right away. Earlier, it waited until the dynamic content was loaded before being enabled. Here's some information that will make this entire video worthwhile. We're about to shorten hours of debugging into a simple, little-known fact. When we reject our deferred object, that immediately rejects the deferred object used by the when block. That causes the fail to process and also causes the always method to immediately process. See, once the state of a deferred object is established, it can't be changed. Let's take a look at what our logic flow is. The way we've written our code, the logic flow could easily be stated as: when processing these embedded functions, run the done function immediately upon success, or run the fail function immediately upon failure. Then run the always function right away too. That's exactly what is happening in this case. Since we've purposely introduced negative tests into this process, we're encountering something that may not become apparent for a very long time. Under normal circumstances, this situation may not present itself for months. When it finally comes up, we will be working on some other project and we'll have to relearn what we've done on this project. Let's take care of this right now. Now that we know what's going on, how do we approach it differently? What we really want our logic to be is, when processing the embedded functions, report errors to the message area and keep processing. When everything is processed, enable the Proceed button. The key point of that logic is that we're handling the errors directly in the load section function. There is really no need to ever reject the deferred object that we're using. Once we report the error message, we can really resolve the deferred. Keep in mind, the only thing we're doing in the fail logic is duplicating the error message. Let's change all our reject methods to resolve methods and see if that gives us what we want. We've changed all the reject methods to resolve. In those cases where we called reject with a result, we can still pass the result with resolve. We just won't be using it. Let's run Firefox again and see how things work now. Remember, the Proceed button was enabled before the dynamic content in section 3 was loaded. Now that's more like it. The Proceed button doesn't enable until after the dynamic content is loaded, even when an error is present. This is a very important point to take away from this video. When we write our logic, we must consider what will happen when, not if, we get an error. We must ensure that our logic doesn't fall apart just because of an unexpected circumstance. Let's throw some more error situations at our load section function. Remember how we tested with no parameter? We'll put that test back in. Let's also add an empty parameter object. Let's check what happens with these two new errors. We get all our error messages, and the Proceed button still waits for the dynamic content. Our failure processing is working well. Speaking of failures, we looked at content 3b. It's the one that raises our custom failure event. Let's load that instead of loading content 3a. Let's also test the error we get when we pass in an invalid selector. Finally, we'll change content 1bb back to content 1b and change the dynamic property to false. This should test what happens when we don't look for our custom events. Keep in mind, content 1b has the extended timeout of 5 seconds. If we don't set the dynamic property to true, the load section function won't know to wait on the dynamic content. Here we go. A lot just happened. Content 1 loaded, and there was no problem with the dynamic property set to false. The dynamic content still loaded, we just didn't get a proper notification of when it completed. The Proceed button still enabled as soon as the content in section 3 was loaded. In this case, the error lies with the programmer, not the function. All we have to do is change the dynamic property back to true, and the process will behave as we expect. Let's run this one last time. Fixing that problem was easy. If we could fix all programmer problems so easily, we wouldn't ever have to worry about sitting in a cubicle again. We've come a long way with our deferred processing. If we take anything away from this segment, it should be how important negative testing is when dealing with asynchronous processes.